There are three main elements that are essential for the function of any synapse. The first we will consider is the neurotransmitter. Neurotransmitters are released in large numbers from neurons to transmit information to other neurons. There are different types of neurotransmitters, each being involved in different functions and in different parts of the brain. In this movie, you will hear a lot about dopamine and serotonin, because these two neurotransmitters are important for mood and pleasure and are often the target of recreational drugs. The second element are receptors. Receptors receive the neurotransmitters and transmit their information to the next neuron. Finally, another important element in synaptic transmission is the reuptake pump. The job of the reuptake pump is to clean the area between the two neurons, the synapse, when the signal has been transmitted. This allows short signals to be transmitted without lasting too long, and it also enables the nervous system to recycle neurotransmitters. The way in which each neuron communicates is delicately balanced. This balance continues to be modified as we develop and learn new things. Each neuron sends just the right amount of neurotransmitter, and this communication forms the basis for all of our behaviors. Drugs will exert their actions on the synapse by modifying one of these three elements: the neurotransmitter, the receptor, or the reuptake pump.
We've begun to understand that actually most of the drugs of abuse, the common drugs of abuse like amphetamines, like cocaine, like heroin for example, they end up one way or another, directly or indirectly influencing the release of neurotransmitters in the brain, in particular the release of one critical neurotransmitter which is called dopamine. And they do that by different mechanisms. For example, cocaine acts by blocking a mechanism that we call reuptake, and therefore what that will induce is that dopamine will stay outside the cell for a much longer period of time, and therefore it will have much more of a chance to activate these receptors. So the effects of dopamine in the brain will be multiplied by this effect of cocaine. Amphetamines end up doing the same thing in the sense that they end up releasing more dopamine in the brain, but they will do it through a different mechanism. They will actually facilitate the release itself of dopamine and not only its reuptake in the cell. It's acting differently, but in the end the final effect is relatively similar in the sense that it will lead to an accumulation of dopamine outside the cell. So the neurons that normally receive this message mediated by dopamine will be stimulated more than usual for a longer period of time, so an unnatural period of time.
Cocaine. Once it enters the brain, it blocks the reuptake pumps in certain neurons. When these reuptake pumps are blocked, dopamine is trapped in the area between the neurons. Because dopamine cannot be reabsorbed, more dopamine is present in the space between the two neurons. This results in overactivation of the receptors. Amphetamine, known by the street name speed, acts through a slightly different mechanism than cocaine. However, amphetamine also causes more dopamine to be available in the synapse, leading to a similar effect on synaptic function. Each drug changes the activity of some neurons in the brain while leaving other neurons unaffected. The specific neurons that a particular drug acts upon will determine the nature of the drug's effects. Marijuana, also known as cannabis, works differently than cocaine. Marijuana contains an active element known as tetrahydrocannabinol, or THC. Instead of blocking reuptake pumps, THC acts directly to increase the activity of a certain type of receptor. These receptors have been named cannabinoid receptors. Many drugs produce their effects by activating certain receptors in the brain. This is also the case for nicotine, which is the addictive substance in cigars and cigarettes.